I'm going to enter the data. Here's a research example. We're going to work out joint class. We have two variables, x and y. 1, 2, 3, 4, 5, 6. 6 people in each group. Well, I should add a column. Add a column. Insert a column to the left. Participants. Number 1, 2, 3, 4, 5. Oh, five people. 5 people. 5 people. Each person gives me 2 numbers, x and y. First, you define the variable view, x name, x variable, type numerical. Let's do 2 decimal points. Y, also numerical, 2 decimal points. Now ready for the data. The data x. That's x. How about y? Yeah, let's first calculate the basics, statistics. I'm going to move this up a little bit. Move the recording window up a little bit. Here. I'm going to get the mean. So I go to the analyze, descriptive statistics. What do I want? I want x, y. These are the variables I want to analyze. Mean, standard deviation. Yeah, I want the sum. And variance. Variance good too. Okay. The mean for x, 6. Mean for y is 4. Standard deviation. So, now I know the mean and the standard deviation of x. I can calculate the z-scores for the 5 people on x. I can do the same for y. Let's calculate the z-scores for x. The mean is 6, standard deviation 2.45. For z-score, transform. Here you have transform. Transform, you have compute. I'm going to compute, yeah. First, I'm going to compute the deviation score for x. X deviation. Deviation means the value of each x minus what? Minus the mean. What's the mean for x? Mean for x. Where's the result? I want to look at the result. The mean for x, I believe, was 6. Here, output, okay, 6. 6 minus 6. It's okay. Alright, here I have each person's deviation from the mean. Subject number 1, below the mean, 2 points below the mean. The last one, number 5, above the mean, 4 points above the mean. After getting the deviation score, I can get the squared deviation. Again, compute, reset, deviation, square it, raised to the power of y. I'll just make it easy. Time itself. Time. See if it works. No, it doesn't work. Compute. Do I have a function called square? Square it. Square root, again, guys, square root. Square root. Yeah, I wonder if this one would be the... No, it doesn't work. Okay, well, I'm going to get z-score directly. Get a z-score for x, zx. The z-score is how many standard deviations each score is away from the mean. So you have x minus, what's the mean? 6 divided by, what was the standard deviation? 2.45. 2.45 divided by 2.45. Okay, we got all the z-scores. For x, now I can get the z-score for y. Z-score for y, just replace x with y. No, the mean changes to the mean. Where's the mean? The mean for y is 4. Standard deviation the same for 2.45. So I have to change the mean. Minus 4 y minus 4 divided by the standard deviation. The standard deviation happened to be the same for both variables. I set it up to make it easier to calculate. Now I have z-scores for x and z-scores for y. Now I need to get the cross product of the two z-scores. This is called cross product, or just say zx cross product, easier to do. Zx times zy. Dx times dy. Now I need to get the sum. Get the sum of the product. Okay, no, I don't need this function. I need to analyze. Analyze. Get the descriptives. I don't want any of this. I just want the sum. Oh no, I think I got it wrong. No, I don't want sum of x, sum of y. I want the sum of the cross product. Descriptive. I don't want this. I don't want this. I want the sum of the cross product. Okay. 3.66. 3.66. 3.66. Divided by 4. Yeah, so this way r equals to 0.915. This is a correlation coefficient. I calculated using the old-fashioned way, the slow way. 0.915, the conceptual formula which we discussed in class. And there's a faster way to calculate the correlation coefficient. Bivariate, you just try to get the coefficients for x and y. Let's see if they match. 0.917. Yeah, there are some rounding errors. Given some rounding errors, you get the same number correlation coefficient. That's good.